Welcome back to CodingCat.dev, where we give you cats the freshest dose of dev snacks. Brought to you by Cloudinary, build faster with AI-powered image and video APIs. Need better search? Try Algolia, powering discovery. Hey Satish, how are you?
Hi Alex, good morning. I'm fantastic. How are you?
I'm fantastic. Welcome back, perfect peeps, to CodingCat.dev podcast, of course. We're going to dive into some infrastructure, but first we're going to get to know Satish a little bit more and kind of his background and his history and everything that, brought him to where he's at today. And kind of where I want to start this is your Bachelor of Engineering, Computer Science. You're over in India. What was that journey like, and kind of how did you get started with it?
Yeah, sure. Right. So I did my schooling back in India. I grew in a family of three brothers, so we all were in the same thing. Like, okay, you need to do engineering to get a job and all that kind of traditional family pressure stuff. Luckily for me, I was always fascinated by computers, and I chose computer as my stream of study in my Bachelor of Engineering. So that was an easy choice, and I did my engineering. I got placed in my campus interviews, and then I started working for a company there. Like
Your
4 years.
primary focus during college, was it like Java oriented? Is that kind of what the language was for you?
So they don't teach basically languages
Okay.
in the college. It was more of concepts like data structures, algorithms, networking, and all that stuff.
That's awesome.
Um,
I
but
know, like, I started out in like actual engineering, like mechanical engineering. I was going for civil engineering, and I took my first course in Java, and I loved it so much. That's what drew me into computer science. So I'm always curious, like, what people are into.
that's amazing, and I can resonate that because I love Java, and that's why I have been always a Java developer for like 16 years now. So one thing in my school, at that time, even when they introduced me to program languages, they did not teach it completely. It was C. C was a real thing at that time. So
Yeah,
right.
yeah. Still in engineering, I think it's still probably the most common used language. Maybe Python at this point, but
Yeah. So I remember my days like when I was in my school, even before engineering, the very first programming language that I got used to it was Basic, some parts of Fortran. So
wow.
and using Turtle logo going and then writing like 4 lines of command. I see a square on the screen. I'm like, wow, I created a square. So that's where the passion comes from. But anyways, I joined my first job, and that's where I started getting into Java. And I always loved Java, and get too much interested towards it, and continued on that. So I moved here on my work visas. I worked for a bunch of companies, starting with that monolith Java applications, going to microservices and all that. And around 2015, I guess, like 10 years back, the whole AWS thing came in, and
Yeah.
then I moved into this microservices infrastructure related work. So that's the job where I shifted multiple areas. So I was working on pure backend services coding, and then I moved to data engineering, where I worked on Spark, Scala, Kafka, all this kind of new things for data streaming stuff, working on Parquet files, S3 storage, and all that. And then during this process, I was very closely working with my platform team. They inspired me a lot, so I became a DevOps engineer, and worked for a couple of years as a DevOps engineer, and had this infrastructure and development, both of
Yeah.
them being my favorites at this point.
And like DevOps can span like a broad amount of things. For you, like, what was kind of your primary focus, or like what was your day-to-day tasks?
So I was more on the front end part of it, which is the deployment pipelines. So we took the challenge of reducing the the time the pipeline takes. So that's the first time they even gave me admin permissions on a Jenkins server or anywhere, right?
Yeah.
So I started there, but I also went into the Terraform and all the scripting behind the scenes for infrastructure procurement, and that gave more command on what we suggest and recommend from a platform team perspective as should be the infrastructure that the company should be using, or based on the services and all that. So my area was more about choosing the right services, AWS services, and procuring them.
Oh, nice. That's really cool. And so, like, when you start to break down, like, it's CI/CD, kind of that pipeline and slowing things down, or speeding things up rather when things are slow. were you looking at like the programming parts of it, or were you like, hey, we need a bigger build server? Or like what kind of analysis did that take for you?
So I was looking at all parts of it, to be honest, right? So since again, that's the biggest benefit. Like when we come from a programming background, right? We know what's going on there. So one of the key things was trying to automate the testings and then getting into that parts of automation in the coding side. And then the other parts were mostly focusing on not on the exactly on the size of the servers or something, but trying to cut down the unnecessary steps and trying to parallelize some activities in different environments. And then this happens in many companies, right? Believe me, right? We go into this AWS and then we say, oh, we need dev environment, we need QA environment, we need production environment. No one uses the dev environment. It's like we buy the servers and keep it aside, and everyone jumps onto QA and say, "Oh, the data is perfect in QA.
Yeah.
Data is bad in dev. We don't want that." So
Yeah.
those are some of the problems we were trying to address, and then trying to say, you know what, we need to streamline this process and also make use of the money that we pay to AWS, right?
Yeah, for sure. It's always challenging too, because like a lot of data, especially nowadays, that you're like, yeah, we could bring that into dev, but then people have access to it, and we have all this PII, and we have X, Y, Z, and like there's so many restrictions, but like you
Yeah.
still want to be able to scale and like program around things that are large, but you can't. So it's always a fun challenge in those different environments for sure. Talk a little bit about like kind of your next step. You then started like a company like 5-ish years ago, right? Talk a little bit about Y Combinator. I'm so interested.
Sure. Like so, yeah. 4 years back, my friends and I we started a company that CloudPac. So that's a company again. It is more focused on solving infrastructure problems for companies. So again, it was an idea that was born on a late night when we were trying to solve a different problem. We are like, you know what? Why there is no solution for this? And then we thought, like, yeah, maybe this is what we should be focusing on, and that's where the idea was born. And then we started working on that. We did a POC kind of thing, but it was not again very early stages, and we knew what we are stepping into was really big, right? So initially we thought, maybe we can do it, and it's like, no, this is too big for us to do. And then that's when we started going to YC and all the VCs. Unfortunately, we did not make it, but and again, because of other personal things that came up in everyone's life, we had to take slow it down a little bit. Good thing is we are back on track now. We actually targeted for this winter season, but yeah, we thought, like, we'll get some more customers and then just pitch them the next time in June timeframe. So next year probably we'll going again for another round of pitching to VCs. So
And it's talk to the people like a little bit, because like I myself haven't done this. Like, what is it like trying to pitch or like come up with that pitch and like practice it, and like when you're about to deliver that, what are the feelings around it? Like, give me the whole shebang.
So for the very first thing, right, this whole experience was completely new, right? Like we had no idea of what we were talking about. We were all like bunch of engineers, and we have worked so much into our companies, into projects, leading projects, and all that stuff. That experience is completely different from startups, right?
Yeah.
So it was a big learning curve, and the way that we even looked at things was not from a programming lens, but from a business lens, which was completely different. So I couldn't even understand how to create a pitch. So it took a long time for us to get to that, a long number of iterations to get there and understand the finances and all that stuff behind the scenes, right? Like how much we ask for and why do we ask for that and what is the percentage and all that stuff. So luckily, one of my friends in our group, he is more good with numbers, so we used his help. But it was a totally complete different experience. But I see that as a very good opportunity, because being in the tech field for so long, we always see that there is a group of high leadership or the top management that make decisions, right? We don't know why they make the decisions. They say it and then we do it. This experience gives a very big insight of how those decisions are made and how we have to make those decisions with market conditions. So that's a very good experience, I believe.
That is really, and like it helps you take like a step back to really say, okay, like we know engineering wise why we're doing this, but like why is the company doing this thing? Like what is our revenue basis points, and like how are we actually going to earn money? And like I think it's that moment where you go, well, we're asking for money. How are we actually going to spend it? Like it's a huge and important aspect around that for sure.
Yeah, I'll
And
tell
I
you.
will say, even after you get money, most startups I've worked for still don't have answers to those, but it's a good idea. So,
And you know what the thing is, right? Like sometimes they say the best way is to learn is by making mistakes, right?
yep.
So if I go to Google and then say what are all the mistakes, common mistakes that startups make, I can see that I made every single one of them. Right? I'm like, okay, I'm going to start with the perfect architecture with microservices, 10 different services to deploy. That's like too much of pain, right? Like
Yeah.
just get the functionality out. That's critical when you're a startup. So yeah, we made all those mistakes and learned. And I think hopefully the next iteration is going to be much more. Much more towards not making those mistakes and then trying to get the right things done. Right?
I can't remember the exact phrase, but a colleague at work just said, what should we work on next? Is it performance? Is it user experience? Blah, blah, blah. And she basically said, if people aren't going to use the product, you don't have to worry about performance. Trust me. So like kind of just getting those eggs in like a row and like making sure all of the product pieces for your users is actually going to work, and always being able to like take their input and like really tweak that thing is so important. And we're going to talk all about that after we come back from break. We're going to talk about infrastructure-driven development and how it can help you. We'll be right back.
Cloudinary allows you to remove any unwanted backgrounds, so you can reuse assets efficiently. You can also erase objects and people from images for placement in new experiences. For more engaging content, easily turn static images into dynamic animations, and rely on smart cropping to always deliver assets with a focus on the most relevant objects to your brand. Cloudinary Programmable Media. Build faster with AI-powered image and video APIs.
Algolia helps you create a search and discovery engine in 3 steps. Step 1, import your data. Import the API client, initialize the client in index, load the local JSON file, and then push to Algolia. Step 2, configure relevance. Define searchable attributes, add business metric, specify facets and filtering. And step 3, build your search UI, import widgets from the library, add instant search component, add search input, refine by attribute, display results, add pagination. And just like that, you're done. Build search effortlessly with Algolia.
Welcome back, peeps. We're kind of going through Sathish's background and like learning all about how he went through Y Combinator and came over from India and like has been working in infrastructure and development more specifically for 15 years now. It's kind of incredible. But now we're going to break into, if I click it right, infrastructure-driven development, which is awesome. If you ask me, Sathish had hesitation. He said, "I don't know about this title. It's like fake," and I'm like, "I love it. Like, this is a pure marketing title. It's perfect."
Right.
So in my mind, when I think of infrastructure-driven development, the first thing that comes to my head is like Terraform or like Pulumi as infrastructure as code. Is that kind of what you're thinking too, or is it just like slightly different than that?
No, it's completely different than that.
Okay.
So that's why I said this is a made-up word, because
make your thing. IDD will be so famous by the end of this podcast.
yeah. So the goal or the point that I was trying to focus here is right. The programmers when we create applications, and again, I'm going to narrow down this discussion to backend services, and to make this really impactful, right? So if we go into as an engineer and then start writing some code, all we think about is functionalities, right? Oh, I know this programming language. I need to solve this functionality. I need to solve this problem. This is how I'm going to code. But nowadays, that is not sufficient. We need to be aware of where this code is going to run, right? So that is what I wanted to highlight, saying that when I say infrastructure-driven development or infrastructure awareness, it's like we need to be aware of where this code is going to run and how it is going to perform. And that impacts a lot of decisions we make in our coding.
100%. Yeah, and especially like when it's not just like where it can run, right? It's like how not only this like API endpoint and where it's running, but like what other thing does it have to call, right? Like if your database is in like Virginia and you're running all your services in India, what kind of impacts does that have, right?
Exactly. Yeah.
And so do you find like programming in this way, like nowadays microservices, you're in the cloud, is like that the first step, like the architectural diagram, or do you find people are still like, just, I got to get that code out because it has to do this thing and we'll worry about that later?
So this is how I see with my experience, again, with the teams that I have been working on, right?
Yep.
15 years back when we started, we all had some levels of this awareness in our mind, but that was more related to resources, right? We said, okay, you know what, we don't want to put something in the memory and leave it there. We don't want to get an out of memory exception because it was very common at the time. We don't want to have some kind of thread stack overflow exceptions and all that stuff.
Yep.
Over the period with the cloud, the resources became limitless because, oh yeah, your resources is not sufficient, just increase it, right? So this limitless increasing has made people less aware of those kind of resource intensive codings, right? That's number one. And in recent days, what I see is the companies, architects who design these solutions, we see a lot of left shift infrastructure, right? So people make decisions. Okay, this is going to be running on an AWS Lambda. This is going to be running on a Kubernetes pod. Even before we talk about creating the application, the decision is made, and then we say, okay, this is what we are going to do. But after that, throughout the coding, we don't go back and then make sure that what we do is going to work with that, right? We don't keep that constant evaluation in our mind. So that is what is I feel is missing. Especially when engineers focus getting into the coding, getting into their mic, put their headphones and then go into a silo coding mode. I think that's what is missing, and that is something that we no longer take and take that as an excuse to be not aware of it.
And what kind of tools help developers like at least start to think that way, and then also like monitor that progress?
So I feel that more than tools, it is just like having that as a thought at the back of your mind to make sure, okay, you know what, this is what the functionality should do. But again, even before that, the key thing is understanding the infrastructure, right? We never had a need as a programmer. We never had a need to understand what the infrastructure was earlier. But now, especially if I'll like, just for the case study, right? If we take an example of a Kubernetes container and an AWS Lambda, which is a serverless architecture, right?
Yep.
Sounds fancy when I say, oh, I use Lambda, I don't have to manage the servers. But that means there is a lot of things that we need to know when we code, right? So even as a programmer, if I don't care about infrastructure, I need to know what limitations or how Lambda would work, and what are all the things I need to be aware of, right? Like gotchas.
Yeah, so like cold starts and like what
Exactly.
scaling actually look like, stuff like that.
Yeah. So that's in fact one of the point that I wanted to mention as well. Like it's an issue that we faced in our team, where we said, oh, you know what, we'll do Lambdas and then we'll do it. It's serverless, but the most important thing is it's single threaded, right?
Yeah.
So every request that comes in creates a new instance, and there was a cold start. So every instance was taking like n number of seconds to start, and it's like, oh yeah, the first 15 requests are always going to be slow, or the first 30 requests are going to be slow. And what happens after 15 minutes? If you get 100 requests, oh, they're all going to be slow.
Yeah.
So
yeah, it's always fun stuff to think about. I think it's difficult too when you think of maybe like older developers like myself think like in a full stack, like a EC2 is up and running and like you're just hammering away on that and there is no cold start. So you're like, oh, I just program like normal. And like now in the last 5 years, somewhere in there, like they have improved cold start times so much where you can even set like most of these to like have one running all the time, so you don't even get that impact as much, I should say. And we've seen the trend kind of go back, and I always talk like this kind of like pendulum rocking back and forth between like this mainframe attitude versus like completely disparate and like whatever the word I'm looking for, cross systems. And like now it's kind of swinging back where like, hey, we need all this compute again, and it needs to be in this one area. But like we have all these new technologies that can scale out and scale up like infinitely, to your point. How do we solve this one little case? And like as we've run into those as engineers, and like AWS, sees this over tens of thousands of customers, hundreds of thousands, wherever they're at now, they can actually implement like, hey, we're not going to have cold starts anymore. We're not going to do this. And like they improve each little piece. And I think a lot of people, especially on the web side of things, they feel as though like when like Next.js came out and static pages were like the first thing, and then they're like, oh, we don't really want that exactly. We want to be able to like regenerate a page on demand. And now we're all the way back to, and we're just gonna run everything server side again. And like people just kind of say, oh, we're back where we started 10 years ago. And it's not the case. Like all of this is kind of additive. Like we're learning, and there's new technologies as you go along too. Sorry, I went on a crazy rant there, but
no, but that's totally true, right? And a couple of points that you made is like it's absolutely the fact, right? It's like a pendulum, right? So we see that it started somewhere and then it went into a direction and it is coming back, but there is that's the balance that the industry is also trying to find out, right? So that AWS is trying to solve lots of problems, and they have made so many incredible decisions throughout this, right? But again, the goal for AWS is that we want to simplify things for you, and it starts there, but it cannot be staying there for long, forever, right? It started with that saying that, okay, we are simplifying this for you because I'm giving you an EC2 instance. You call an API and then you get the server. And then down the line, they're like, oh, you want compute? There are like 100 services. You can pick one of them. Yeah. And each of them has pros and cons. Now, you have to be aware of all these things and which one suits you best, right? And then, okay, this has patching, this doesn't need patching, this needs that, and all that kind of craziness comes in. So it is trying to solve the problem, but as you said, every step we try to solve the problem, new problems come because we are advancing in that technology. And then that's a good, healthy thing, right?
Yeah, 100%. And I think like the other piece to all of this, and the reason we want it to be so efficient is, and a lot of people don't talk about it in engineering, but it's costs, right? Like
exactly.
At the end of the day, like I don't want a server sitting there doing nothing that's costing me 10 grand a month, like period. So that's where kind of that serverless mentality comes in. But with serverless, like there's trade-offs, just like we're talking about. And so like you start threading things up like crazy, or your authentication, like on Firebase, like you're a piece of cake for a long time, and then all of a sudden like you hit this limit of like not a million, I don't know what the number is, but yeah, you'll hit a number and you go, oh no. And so like that's where my day job, Fusion Auth, comes into play, where we're like, well, we kind of approached it differently. Like we took that Java VM, which you're familiar with, the Java stack, and like threw that into Kubernetes, and that's where you sit at, and like that's yours. You don't have to worry about your millionth user. It's the same cost almost, depending on what you're doing, as like your first user. And so there's those trade-offs that you kind of go into first, and there's times like as a startup that you're used to, you're like, I have a problem, I need a solution, it has to be easy and quick, and we'll figure it out later when we need to pivot, right? But when you start to get in this infrastructure driven development side of things, and you've made that decision 3 years ago, and now you're feeling the pain of that decision, it's worth like taking a step back initially and going, what happens if we're at this growth level or this growth level, and how painful will that be to like us and our customers when we hit it? I think cost is a big part of this equation.
Yeah, and I'll try to keep my marketing outside of this, because that is one of the problems that we are aiming at CloudPac as well, right? Like, because most of the companies get into this, like, oh yeah, we made this decision 3 years back.
Yep.
And we spent so much on it. Now, can I go back? And then it is too big for them to go back, right?
Yeah.
And again, that is a very big challenge that companies face. So we keep going into this, and then immediately there will be a separate team that will be formed. We will say, okay, we are focused on reducing the infrastructure costs, right? So come on, talk about take all your unused instances, do this, and all that stuff. But
I think it's difficult too, like when you've made those decisions as well, but like some of those things take a long time. So I worked at a shop where we were implementing SAP. At a large company, that takes years, like multiple years. And they switched technologies within that, where they went to like all in-memory database with HANA. And it's like, okay, well, now we have to make a decision. Even though we're like fully on the application implementing, do we pause and like upgrade the infrastructure that we're on too as we're doing this? And it's like, we kind of should, but here's the impacts that it has, and like it'll speed things up in the end, but it make things worse now. And like there's that whole architectural piece you have to go through.
Yeah, and this reminds me of another challenge. Like, one of the teams, they said, oh, you know what, we will go to AWS Lambda because it's cost efficient, right? But their actual application, the monolith application, still uses an Oracle database. They said, okay, you know what, let's put this Lambdas and then talk to the Oracle database. Guess what? bunch of requests comes in, and then every single connection is a Lambda instance is going to create its own connection to the database. And the database is like, okay, I'm out of the connections. You cannot make any more connections to me, right?
Yep.
So there is all these problems that we engineers at least don't think of upfront, and that is the problem it creates, right? And to the cost part, right? I read an interesting article like a couple of days back. It says that in Kafka, if for you to move 30 megabytes of data, it costs like probably $100,000, right? And it says the storage is going to take only probably like 30K of that money. The remaining 70K is because of your network in and network out cost, right?
Oh.
Because AWS charges you money for the data that comes in, and it charges for the data that goes out. That accumulates to that cost, right? And we don't even think about it. We just think about, okay, you know what? I'm going to keep probably 30 MB of data in Kafka, and how much it is going to cost for the storage. No, it is not just that, right?
Yeah, that's a good point. And like, again, this gets back to like thinking about kind of what your infrastructure needs to do, and like how far into cold storage do you put things, and like how that like warm storage or whatever, and then like truly hot. And like typically when I was always doing price breakdowns, or modeling, when I was kind of in that role, like I would look at it as most of my network stuff should be on these hot warm reads. I never thought about cold. The problem was every once in a while we'd have a cold request come in to dump that stuff into like BI storage, and like here ramps up our costs like crazy again. Even though like we only touch that stuff like once in 5 years, we might touch it all once in 5 years, and so like you don't think about it.
Yeah, and I have at least heard this from like 10 to 15 companies that are in a close circle, right? Everybody faces this. Everybody is like, yeah, we started this. Now we have some projects going on, which is to reduce AWS costs, right? So yeah, cost is a very important factor. And again, when we think about performance, that's what we compromise on the cost, right? Like we say, oh, you know what? Memory is cheap nowadays. Yeah, it looks cheap. It looks cheap when you see it as 0.002 cents, but when you accumulate it, it's like huge. It's a huge bill that you get by end of the month, right?
I will say compared to 10 years ago, it's very cheap.
That's true. But again, that's where this whole thing comes as a critical point from my perspective, right? So yes, we knew at least like getting service wasn't easy at that time, right? It was expensive. So getting a machine was expensive. So we didn't have this horizontal scaling at our will. Now we have horizontal scaling at our will. So we just take it for granted and then say, yeah, I can scale my application to my performance. Well, you don't need it. If some of the things can be taken care by the coding, when we do that and when we think about all those things upfront, shift left, some of those things are not needed, right? We don't have to do it and then see that as an issue, come back to fix it.
Yeah.
Right. So that's where the infrastructure awareness is very, very important in coding principles in my mind. Right.
So if we take it like for a minute and say a lot of people that listen to this podcast are kind of front end developers, and they might be interested in DevOps and things like that, where would you suggest to kind of start to learn like that next phase of your career of like, I should be thinking about infrastructure. I can't just think about like what I'm developing anymore, or at least like start to get into, so you could say to, you know, your lead or your manager or whomever it might be, and say, hey, I know we designed this way, but have you thought about X? Like, how do you start to build yourself up to understand how to do that?
So, and again, for front-end engineers, this is what I have felt. And again, I'm not an expert in the front-end, so you might help me there. But I've seen some of the people that I work with, they're very, very keen about the data they get back, right? Like when it goes to microservices, we always say that, okay, this is what the logical entity, or this is what the limits of my microservices, this is what the data I would give. You need some other data, go to a different service. So what it does is it puts this pressure on the UI that they have to call, like front end has to call multiple services to get the data they want. Yeah, we have GraphQL, we have Apollo in there and all that stuff, but they still say, my UI developer says this, right? Like if I give him 2 maps and then say you have to look up for each ID in this map, look up the values in this map, he's like, that's too resource intensive. I'll not do that on my browser. Some people run my code on a mobile browser. I will not do that, right? I'm not doing that. You map, do that, and then give it to me. I'm like, I don't want to do that. I don't care. And the points that he thinks about, he probably wouldn't care about running it on an EC2 versus Lambda. But what he thinks about is, what is the network cost? What is the size of the payload that you send me over, right? And from where to where? Like if the requests are going to be to Oregon, right? Are the data sitting there, or am I going to be routed to a different data center? And then what is the latency that it adds to me?
Yep.
So those are the things that they are very, very keen about, and that's the first step that they take towards it. And sometimes the even the URLs, right? Okay, now I'll call, if it is a Canada or UK, which again has data regulations, right? I will call a different URL. I don't want to call a US URL, see that it is coming from there, and then get it routed back. No, I'll completely design. So those are some of the things that my front-end engineers always think about. So they focus that the browsers shouldn't be having too much to run, but at the same time, my network data and the latency are the key things. So whatever I need to do with related to infrastructure, for that I'll do that. This is what the.
Are you feeling people like doing a lot of pushback, and like I'm just basing this on trends between kind of some of the React frameworks like Next and what's the other one? I can't remember, the one that Shopify bought. Anyways, when they're kind of seeing this over and over, where they're saying, hey, we're calling too many APIs, even with HTTP2 and like all of that stuff. And so now they're kind of pushing back to have those kind of either merged at the server level or like cached in a way that's more performant at the server level. Is our teams like seeing that and okay with our like API team like talking with them and saying, hey, can you guys do this for us because it doesn't make sense on the front end? Or do you think that's kind of the trend we're in right now?
I would say yes. I had seen that happening a few times at my present work, and also in a couple of other companies. So when this happens, that's where I go. Like I go to my friends and like, what do you guys do here? And some people do have that because every company is again focused on showing the better performance to their customers. And so that's where this gets into this mode where you talk about all the architecture design principles, but it is not giving me what I want, and I don't want to do this in the front end. I want everything to go to the back end. So I don't know if there is a standard solution yet for that.
Sure.
Because Apollo, at least, there is GraphQL, but Apollo at least is not doing everything that can be done. So there are other service-oriented layer architecture, right? The SOA layers that we worked on years back is kind of coming back.
Yep.
So we have microservices at the back, we have front end at the back, and then we have another layer of server-side coding that sits here, who is just doing this SOA architecture. So I see that as a little bit of trend popping up. But again, I don't know if it will be long-lived or if there will be alternate solutions for it.
Yeah, that's fair to say. I'm also interested if we talk greenfield, like just you start to lay out a new project, and let's say it's based on your current company. You're working at Bill, right?
Mm-hmm.
I think we can talk about that. So you're at Bill.com and you're like, hey, I'm going to make this amazing software platform. Where do you start day one? Do you say, I need to figure out where we're going to host it first? Do you say, where do our databases belong? Do you say, here's the front end language we're going to start with? Like, where do you start from an infrastructure driven development mindset? Where does that go first for your architecting?
So a little bit of all of them. The programming language is probably the last one. That's the last choice that we make. And the decision for that is also sometimes simple, right? It comes from a different angle perspective that we'll never think about. They will say, you know what, we have people who are expertise in this language than this language, so maybe we should go with this, right? So that's the reason most of the time it comes with. But what we decide first is about the infrastructure, right? Whether it would be what kind of compute is going to be. And even more important is the database, right? Because we did land on this problem, like when the companies make this decision saying that, okay, this is what the database that everyone is going to use in this company. There's no one solution to fit all, right?
Right. And if you need transactional, like go Postgres. If you need like something else, you're AWS. I've been out of the AWS world too long. What's
the DynamoDB?
Was it? Yes, Dynamo. Thank you. Jeez.
Yeah. So that's exactly what happened. Like Dynamo is cheap, so we said, well, let's use DynamoDB. But modeling with DynamoDB is really, really complex, right? Because it's not SQL, it's no SQL, so you need to know every single access pattern up front. It could have been simple with an RDS, which is like a Postgres or a MySQL, right?
Yep.
So those decisions, sometimes they will come back as saying that this is what the enterprise policy is, but we would challenge that. We would challenge saying that, okay, what is the use case and what actually makes better? Because especially between a SQL and NoSQL, that completely changes everything. It completely changes what is going to be built on top of it. So we start there and then make decisions on the database, make decisions on the compute next. And then it goes to the next step, like, okay, what is the performance that we can tolerate with? Should it be in edge computing, or can it be in the centralized server? And then the last comes the programming language. So that's at least how we try to sequence it.
Yeah, that totally makes sense, and that's how I would do it too. But it's challenging too. Like, to your point, if you have staff on site who only has a particular language, and like there's a lot of dynamics, we're kind of making it very simplified. But I did say greenfield, so like there you go. I think if you got a choice, that's how you run it, right?
Yeah.
What else am I missing on infrastructure? Do you want to break down a little bit about like CloudPac and what you guys are doing, or is that too top secret?
It's not top secret anymore. So the whole idea of CloudPac is this, right? Like, as the name suggests, it's a creative name. So the problem is with the fragmented services, right? Like, we take any of the major cloud providers, be it AWS, GCP, or Azure, right? To get one particular stack, like if you take the same thing, like I have a Java with React application, how do I deploy it? Like, there are 100 ways to do it. You can do serverless, you can do EC2, you can do ECS, you can do Fargate, you can do a number of things. Oh, I want a NoSQL database. Do you want Firebase? Do you want Dynamo? That. So for everything, there is like too many fragmented services available, right? And everything comes with the pros and cons. Now, to put them all together, we need to have that expertise. And even if you have expertise to some extent, being a developer, what we would miss is we wouldn't know what IAM policies are needed, what network rules are needed, where do you connect the VPC? So you need to create the VPC first and then do this network policies. And you need to put a load balancer in here and all this infrastructure things, right? So any company who wants to do this, they have to have a DevOps expert or a cloud expert, right? So what our solution, or what we were looking for as a solution, is like, you know what, this is what I want to deploy. Just give me one solution. Just give me one thing that will work top to bottom, that includes everything as a single package for me. Say you use this, it gives me network, it gives me compute, it gives me storage, it gives me all the rules, it gives me security, everything in it. So unfortunately, it was not available. So that's where we started with this. And then so many companies came in the last few years, like Render is one, and there are a lot of companies like that. But what they do is they come with pre-built packages, right? They say, you know what, you can use this and this should suffice you. What if I don't want to use this? I don't have a choice, right? So CloudPac's idea is to use LLM and then get your understand the business needs or the product needs, what you use in a high level, and then try to get all this data collectively and then come up with some stack solutions. Okay, you know what, you can do option A, which will use Lambda, Dynamo, and all these things. If you use this for the traffic that you said, this is what your cost is going to be. If you want option B, that can use Kubernetes, this is what the pros and cons, and this is what the cost would be. And if you want something in GCP, you can use Cloud Run, and this is what it is going to be. So that's the idea of CloudPac. And once we pick saying, okay, this is what I want, it can create the IAC, like a Terraform template or something like that, and then provide that, and then we can use that to deploy it. And the other main goal that we want to push out there is like the same thing, right? Once you make the decision, what if it changes? Because the market conditions, right? Oh, I don't want that. I want to go back to something else. Yeah, okay. Now come back with the new requirements. See what is the new thing is. You get a new stack already. Now the only thing is how we take this data and then migrate it, right? Like, how can the code that I have written here should run here? So that is the part that we are trying to solve, and that's in a nutshell what CloudPac is aiming at.
Yeah, that totally makes sense too. And I'm curious, when is it a conversational piece up front where you're saying like, what product are you building? What needs do you foresee? Like, what are the initial questions that like the LLM can understand to then produce that?
Sure. So the initial questions are like, what is your customer base, right? What is the traffic? Is it seasonal? Something like in like eBay or Amazon, is it going to be seasonal traffic or something?
Gotcha.
Or is it like a normal regular thing? And what are the technology stack that you're comfortable with? Are you comfortable with Python or Java and all that? Because every language, if some of the resources have some language restrictions too, right? So it gets all those information. And then it uses that to come up with these packages saying that, okay, this is one stack that you can use, which will have all these benefits. But these are the watchwords that you have to see, and this is the cost, right?
Do you think you'll get into like on the LLM side? Do you think you'll do like cost comparison for that stuff too? So like, where I'm running Lambda on AWS, and like Cloud Run or whatever microservice on GCP, is that kind of something that you'll take into account, or like you'll ask like, do you want to be in one cloud, or do you want to like the cheapest way to run things?
So that's the next thing, right? So we have multiple options on that. So one is like, okay, giving an AWS cloud. One is giving a GCP stack. The other thing could be a stack that uses compute from AWS and database from GCP, right? Even that can be done. So we include cost in this, but we also have, the idea is to also have some recommendations saying that, you know what, this might look cheap, but if you look into the industry, 90% of the companies do this. People favor this over this. So these are all the regular industry standards. These are all what, or something is AWS is planning to deprecate it. AWS itself is saying that this is not something that we use. So all that kind of information comes in for ranking, and then it puts that out to the customer as a suggestion, saying that, you know what, this is what it is. It's not a black box. It's not something we say, okay, you use this. But
Sure.
these are all the catches. If you have to do it, you have to spend hours and hours of training and documentation. But here is all the information. We have curated that for you. Now, this is what we suggest and we recommend to go with. And if you go with, that is, again, it will show you the cost that you're going to pay for the cloud provider, right? It's transparent costing. And if you want to change it, then later, yeah, we can change it. But this is what, and again, that's the whole idea of it, right?
Yeah.
Like it just, what humans take like hours and hours to do and weeks to do, we try to do it with machines.
Love it. That's so cool. What else am I missing on infrastructure-driven development that we haven't talked about? Anything?
So I think we touched on most of the parts, but again, yeah. So those were the points that even I had, right? Like with respect to the case studies that I had was Lambda and DynamoDB, especially. But I think we covered all of them. I'll just probably give this as like challenges to watch out and final thoughts, right? So for engineers, what I believe is when engineers do into coding, getting the functionality done is good. We are aware of the language. We know what language we are coding, and we are aware of what libraries and frameworks we use. But that's not enough. We need to be aware of what infrastructure that code runs. And why it is important is the infrastructure has resource constraints. It might have scaling limits. It might have some other things like long running or stale connections, life cycles of the containers, like when the container stops and when the container starts, right?
100%.
10 years back or 15 years back, if I put a script on my startup, it runs only when I go and deploy, when I invoke a deploy script. If I do that in Kubernetes, it runs for 100 times a day, right?
Yeah.
So those are the things that engineers should be aware of. And as a final thought that I said, right, the developer's role is evolving. Like we, as a coder or a developer, we are not, we are not expected even to just focus on coding
Right.
alone. The role is
Can't be
evolving.
single-minded anymore. Yep.
Yeah, and the future is more involved, right? The future is more involved. And infrastructure awareness is no longer an option, right? Everybody must have this, is what my thought is. And it is helpful. It helps to make a lot of informed decisions throughout the process.
Totally. Love it. Awesome. Well, we're going to pivot a little bit, and we'll switch over to our perfect picks now. I will go first. Mine is kind of nerdy. Let me remove my banner here real quick. So a little bit of a nerdy thing: HTML, JavaScript, CSS, they all have surveys. Right now we're kind of in the state of HTML survey. So that runs, I believe, till October. Yeah, October 1st. So jump in there, check this out. Pretty easy survey, like to go through. Here's forms. Have you ever heard of data lists? So click heard of it. There's the interested, like they changed it around for the UI a little bit to pick, like, but if you've done any of the kind of state of in the web world, definitely go check this out. Highly suggest all of these so you can like see the results and see like, what am I missing? Like, I didn't realize that was a thing. I don't want to feel outdated. Like, putting tables in for formatting these days is probably not the greatest thing anymore. Stuff like that. So definitely check out state of HTML and fill that one out.
Interesting.
More of a fun pick for you.
Yeah, so this is my perfect pick now. So Rings of Power, I'm a fan of a lot of Rings. I know lots of things about Rings of Power. The original fans did not like it, but I love it. I love it. I love the effort. So I'm eagerly waiting for the episode that is coming on today. And this is this same thing. The faction and the fiction is all together. So yeah, my pick is this one.
How would you compare like this series versus? I watched like the original videos. I did not read any of these books, folks. I'm not that big of a fan. How would you compare the two, though?
So I think it is like slow paced,
Okay.
not as great as the movies. But I think a lot of characters are getting introduced, and the movies had to just focus on the core characters. We get to know a lot of characters. I did not read the books myself, but what I know all these characters because I played a lot of games. I
Okay.
played a lot of games, so I knew all these characters, and I just, oh, this is Tom Battle, and he's here. And when I see those characters, it's exciting, and I'm actually waiting for all new characters to pop up through this. And this is going back in age, the second age of the Middle Earth.
Okay.
So I'm interested because the battle was in the third age, and this is in the second age. So I'm like curious to see more and more.
It's funny with all these like prequel or whatever they call before movies kind of thing.
I mean, I'm just amazed by Tolkien's works, right? Like, how could someone create so many things in their brain, right? So
Yeah.
that's the most amazing piece for me.
Yeah, totally. Same. Well, thank you so much, Sathiesh. I can't wait to see kind of what CloudPac does in the future and where you take off. And I think the world is your oyster.
Thank you so much, Alex. Thank you. Nice meeting you.
Take care.
Thanks. Bye.